Hi, welcome to an exciting edition of game development with 3D graphics programming for shaders. My name is Nate Nessler. This is for Hyperactive Studios. Okay, now before we looked at deferred shading with MRTs or multiple render targets, and we also did deferred lighting, and that's cool, but it took more memory bandwidth, and so it wasn't possible on much older cards. So if you want to support fairly old cards, then you need to do this other technique, which is to do scene deferred lighting and shading without the MRTs, where we do multi-pass, lots more. Well, we're already doing multi-pass, but many more passes versus just 2 passes. So this does cut down on the bandwidth on the card, but you do take a performance hit as far as that goes, because you have to keep evaluating the geometry every time you do the image calculation in the screen for screen space. Let's have a look at that real quick here. Okay, so in order to get started here, you just need to come into your Create here, Effect, choose CGFX, say Next, say Empty, and then put in the name of the CG shader that you're doing here. Okay, so that's what we want to do. And that would be in this case we're going to call it scene deferred. You could say shading and lighting, no MRT if you want. You could say something like that. I think I probably did because that's accurate as to what we're doing, something like that. Then you hit next, and then you would finish it here by hitting the finish button. I'm not going to because I already created one, of course. Okay, cool. Now you're going to grab your code from your previously deferred scene shading with the MRT. You're going to copy that, and you're going to paste it over here in your new shader by replacing it. Now, of course, I've already developed the shader, so let's go ahead and close out that one because we no longer need it. And here I said scene defer shading and lighting without the MRT, multiple render targets here, and that's what we currently have set up here. Now I did go and change the technique name here, and my reasoning for it was this has so many passes I couldn't take same pass 1, 0, 1, 2, 3, 4, 5, etc. That's annoying. So instead I actually started naming things properly. And I know you guys aren't as used to seeing this, but it's very simple thing. It shouldn't throw anybody for a loop. I just can't take it anymore. When we have that many passes, I gotta name them. I can't. The structuredness in myself just can't take it. So I had to name this. So I called it Technique Deferred Shading Lighting. Note they do have a scene deferred shading and lighting, no MRT technique in the shader library. However, it has errors in it and doesn't work. So this one that I'm doing the video here on that I've coded works. So be aware of that. I would say don't refer to the one here in the shading library. Please avoid it, as it does have mistakes in it. Alright, and it doesn't work. So this one works. As you can see, here's the images, but the other one doesn't work. Okay, with that said, same thing here. None of this changes. Now, actually, we don't change much of this, believe it or not. There's really not much of a difference going from the other method for the deferred shading and lighting versus this shading and lighting method. So that's really nice, actually. So none of this changes here. All this stays the same, including going through the lights, all the way through the textures. Yeah, all the textures still maintain the same names and everything. Don't change them. They are going to be identical. Where we really get into our changes is further down here. I'm still scrolling to get there. Alright, now there's a few changes here, not much really. And in this one, since we're doing a single, this doesn't change either for the VS screen here. Don't touch it, leave it alone. The VS main doesn't change either. So none of your VS shaders actually change at all. You're going to leave them the same. Alright, then we come down to our pixel shader, and this is where it changes. And not by a whole lot, honestly, but by a little bit. So we still have our wonderful functions here, but the main thing we have here is these functions are now different. Before we had one that was kicking all three out in one go with the out variable after it and in order here, but in this case we're going to actually say, and I just use the fs out again so I can use my structure like I like, and instead returns a type of fs out here, and this allows me to output the color one and then output the normal, well, the view one comes next here because oh no I didn't, oh but I did, oh but I did, oh great. Well, I just noticed I made a mistake I didn't mean to make. Okay, yeah, let me swap these here real quick. No wonder things looked a little funny. I thought they did. Good grief. Well, that explains everything. These were swapped. I guess mine had a mistake in it too. Yay. Alright, compile. And there we are now with the proper shading and lighting with the view. I was worrying about that, man. I was like, wow, the normals look like they're really changing according to the view. That's because they were. Isn't that odd? Alright. Adam swaps. Of course they were. I was reading in the view for the normals and the normals and for the view. That's why it looked funny there for a second. I just not caught that when I'm going back through it on here. Okay. Very cool. Now everything is set properly. I was wondering about that. Alright. I was like, wow, it really looks different. Okay, it shouldn't. And now it's right. Alright, so here we have our FS out here, and we're setting up our pre-color, and this is right up in this area here. I tell you what, let me actually blow up this code here and make it bigger. Alright. I'm just going to move this over. I'm going to drop this down as we don't need it in our way. And let me scroll this down a bit here. Alright, so we have FS out here, pre-color PS, and then I'm saying open parentheses here, and VS out, space IN, close parentheses, open curly brace, FS out, semicolon, out.color equals float 4, open parentheses KD times text 2D, open parentheses color sampler, comma, in.uv.rgb, comma, 1.0, close parentheses, semicolon. So you can see what we've done. All we've done is really set it to out color here and changed it from color out for that variable there. And then we return out, whereas before we weren't returning anything because it was a void on the return. Now we are returning something, so there we go. But that takes care of it. The FS out here, pre-color, pre-normal here, PS. It's going to let us do our normals. So FS out is our return type here, of course. Pre-normal here, PS, open parentheses, VS out, space, IN, close parentheses, open curly brace, FS out, and then out, semicolon, out.color, and we're still going to say out.color. And the reason why we're doing this, we're not saying color 0, color 1, color 2, is because we're going to do this on a single color channel, and that really helps with our limited bandwidth that we have for images go, and then we're going to output to each image individually. And then this way we're not streaming the memory bandwidth to multiple textures at once, and that's going to save on our memory bandwidth if we have an older 3D card that can't handle this kind of multi-processing of the textures at once, because it just doesn't have enough memory bandwidth to handle it. Now, so this does make it run on older cards. Now, something I want to point out here. This is a slower technique than it is to process as many textures as you possibly can on the card simultaneously. The reason why is you have GL finish, and you'll have these finish commands. GL finish is from OpenGL. You'd have a finish command where we need all the pixels to finish rendering before we can move on to the next execution. So every time we have to do one of these passes, they have to finish rendering. And since they have to finish rendering, we can't actually have multiple things render simultaneously at once. In the case of the multiple render targets, we can. We can actually process these textures simultaneously on the 3D card for all the different pixels at once. In this case, the way we're doing it here, each one of these is a separate pass. We're actually handling them one by one on the processor here for the pixels, and so it's slower. It is definitely going to be slower. But on the one benefit here is that you've actually lowered your memory bandwidth here, and so you're not trying to process as much on the 3D card simultaneously. So this does work for older cards, but if you have newer cards, I would recommend putting more textures on the card. And there's another slowdown too on here, by the way, and that is the fact that you have to process the you have to process the whole geometry for every pass. So that's another slowdown, whereas the other one you did it all in one go. So you only process the geometry once and then you hit all the render targets out at once. But again, you have to have a faster 3D card to handle that. In the case of what I'm showing here, my card is totally capable of handling it. Did try it out on an 8300 NVIDIA card, and that worked too. So you'd have to go pretty old before you couldn't do the multiple render targets. Probably like a 6800 or something like that. But if you need to get back to a much older supported card architecture and you want to support very old 3D cards, then you would need to use this no multiple render targets method here. So this is ideal for dealing with older cards. And not to mention, you could have an issue like where we talked about before. Right now it's just having one shader applied to it, but you have to have all these different textures outputted per shader. And so if you have something like that happening, you may need to actually break it down to this older method here, this method for these older cards, just because even the newer cards wouldn't be able to handle the massive bandwidth you would take on that, and if you have lots of shaders being applied. So this is going to be the ideal approach. If you have lots of shaders, you need to apply it in this deferred shading method and just handle it in more passes, and that's going to be the way you're going to want to do it. But yeah, you're going to be processing the geometry a lot more often than you would otherwise. Okay, but with all that said, let's move on here. So we're going to do out.color here equals float4 open parentheses vector to texture normalize in.nwn close parentheses comma 1.0 close parentheses semicolon. So again, the only thing we really changed is out.color here in place of what normal out, sorry. And then we're going to return out, of course. And just like before, we're going to do the FS out here. Semicolon, close curly brace, another pass. Let's do the other pass for the view. All right. Processing our view pass. FS out here, preview PS, VS out, space IN, close parentheses, open curly brace, FS out, semicolon, out.color equals float4, open parentheses, vector to texture, open parentheses, normalize, open parentheses, VWN, close parentheses, comma, 1.0, close parentheses, semicolon, and then return out, semicolon. Again, we're replacing what? The view out with out.color. Otherwise, it's identical. Alright, so that's pretty much it as far as that goes for the PS. Like I said, this is pretty simple. And then we're going to not have to touch a thing on here because all this stays the same. So nothing changes in here on this. And then right down here at the techniques, this is where it gets all changes. Things change here at the techniques. And the reason why, of course, is because we're doing more passes. So, but I've decided to go ahead and name these passes, all 4 of them, so that we could actually understand and make sense of them and read them. And it's no longer just pass 0, 1, 2, 3, etc. Instead, they go by name, and so things make a lot more sense. And especially if you're looking over code, you got like, I don't know, 20, 30 passes. You need to have it broken down where you can actually make sense of what passes what. And so doing just P0, P1, P2, etc. is not a good method of handling this. So naming them is by far the better way to do this, and that's what we're doing here. Okay, so for this technique here, we have technique deferred shading lighting. open lesson sign here, string, script equals, in quotes here, pass equals color pass, semicolon, close quotes, quotes pass equals normal pass, semicolon, close quotes, quotes pass equals view pass, semicolon, close quotes, quotes pass equals deferred lighting pass, semicolon, close quotes, semicolon. Then close a greater than sign here, open curly brace, and we'll start our different passes inside of our technique. So all I'm doing here is saying that, you know, the first pass here is going to be the color pass, and then the next pass we're going to process is going to be the normal pass, and the next pass after that we're going to process is going to be the view pass, and the next pass after that we're going to process is going to be the deferred lighting pass. And so we're just going to go on from there on down. Very cool. Alright, so let's start with the color pass and let's process it first. So we're going to say pass here, space, color pass, open lesson sign here, string script equals, in quotes, render color target. There's no need to put 0 here because we're not doing multiples, we're only doing 1 here, and they're all going from the color target. So we're all going to the G buffer, but only one G buffer at a time here. Deferred color texture, semicolon, close quotes. Open quotes here, render depth stencil target equals depth buffer texture, semicolon, close quotes. Now again, deferred color texture here is the texture that we're going to be writing to from our G buffer. So it's going to actually have a name in the system, and then we can access it later, at a later point in time. So that's cool. Clear set color equals clear color. Clear set depth equals clear depth. And of course semicolons after each one of those, and they're all in quotes. Clear equals color, semicolon, close quotes. And then we have clear equals depth, semicolon, close quotes. And then in quotes we have draw equals geometry, semicolon, close quotes, semicolon. And of course that's because we're doing a deferred rendering and we're at the geometry process and not doing a pre-process or a post-process. So we're handling it here. Okay, so with that, we're going to have a depth test enabled equals true, semicolon, depth mask equals true, semicolon, cull face enable equals false, semicolon, blend enable equals false, semicolon, depth func equals L equals, semicolon, vertex program equals compile, VP40, main VS, fragment program compile, FP40, pre-color PS, open close parentheses, semicolon. And that's going to get our color one compiled for our first pass here, for our color pass, which is going to be this one here. Okay, so that's going to get that set up. Okay, and let's just move back to, man, of course I would do that. Alrighty. Alright. Let's look at a few other things too here though. Going forward, and close curly brace. Now you'll notice something is identical to the one above it. So you'll notice that our script pass here is identical. We're not changing anything. It's always going to be the same for this part. So you'll have your depth buffer going on here. For each one, they're both going, it's of course going to go to the color target, but this time it's the normal texture instead of the color texture. Because again, we're just going to keep reusing that same G buffer. So we're only going one texture at a time being written and processed across the memory bandwidth. This is why I was saying that, you know, we're affecting the memory bandwidth, not necessarily the number of textures, but the amount of memory. But the actual memory bandwidth for how many textures it can process and stream across the card simultaneously. So that's what I'm talking about, where we can go to older setup here. I'll try a VP30 just real quick. I'm just curious if we can do a VP30 on this one. The other one could not when we were doing the other setup. And it seems to like it just fine. See if I can get away with a VP20. Might be able to, actually. Can. Wow. I'm really curious now. ARB BP1 and ARB FP1. I doubt it. Nope, worked. Wow, cool. Wow. Yeah, that's much older. Well then, that works on much older hardware. Wow. Okay then. yeah, if you want this to work on much older hardware, this is the way to go. All the rest of this is identical, doesn't change, it's all the same. Don't change anything there. So the only thing that really changed in this past part, you can just copy and paste the one above it, is this part right here where you changed it from color to normal. That's it. Otherwise, it's all the same. And then depth test enable, all this is the same. And then right here you say, instead of pre-color here, you say pre-normal. And I'm curious if we can get away with changing that one to ARB VP1 and ARB FP1 or not. I haven't tried. We can. Wow. Okay. We sure can. So yeah, looks like it'll work with these older values in here. Amazing. Let me make sure I'm not getting no errors at all. Whew. Okay. With that, we're going to do pre-normal here, PS. As I said before. Again, copy and paste. Going down here for our view pass. So again, this one's called view. Just like this one was called normal pass instead of color pass. Because don't forget, we're referring to these up here, color, normal, view, for all these passes. So make sure you name them appropriately. Okay. And everything's the same except for, of course, we're going to turn deferred view texture to normal, deferred normal texture. So change the view to change the normal to view. Sorry. And then everything else is the same on that. And then the only thing that's different here is change normal to view down here. So it's going to change this from normal to view. So it says view there. Okay. And I'm curious. I bet it's going to work now. ARB FP1. Okay, that's as old as you can get, man. You can't get any older than that on the hardware. That's amazing. So it's handling it. It's not screwing up. So going on there, and now we're going to go down to our deferred lighting pass. Now this one we may not be able to push it so low, but we'll see. This one's different. You can copy and paste the other one from above, and we just have to do minimal changes to it. Actually, the previous one you had here for that last pass probably doesn't need to be changed at all. You probably just run with it and not have to have anything different. Actually, but yeah, so your render color target is nothing, your depth stencil target is nothing, and then this is all the same from down here, going on down. In this case, this is false instead of true, and this is also false instead of true because we're not going to process it, so no need. And then you just come down here and you're going to say screen VS instead. As you note before, we were having to process the geometry each time we wanted to do one of these passes. So like I said, it does slow things down for the scene. In this case, we're only processing the screen, quad, and then we're actually doing our main final rendering. For our pixel shader, it goes to the screen. And we can see what we can get away with on this. ARB VP1. I bet we can on that one. That should be straightforward and simple. Worked fine. This one, I'm not so sure about. ARB FP1. I'll be surprised. We'll see what happens. It took it. I can't believe it. It took it. Okay. Wow. That's the oldest hardware. So it goes all the way back. Amazing. So you can use this technique on pretty much anything. And there it is, processing it in real time for us to see with literally the oldest techniques out there for shading. And I can't even tell a difference. That's amazing. Wow. Just wow. Unbelievable. Okay. Yeah, I think that's about the oldest technique we've ever... Wow, the deferred shading is amazing. Wow, what a performance gain, though, that you can go back that far. That really lets you support a lot of older techniques, and that's amazing. Okay. Really impressive stuff. So, assuming the cards can run fast enough to handle all the passes on the older techniques, you can really go back really far with this and handle much older cards with this technique. But with that, that covers deferred shading with no multiple render targets, and that's all there is involved to it. I mean, there's really not much to this, and it's really not much different than what you had before. I've been going over some other techniques. I don't want to say for sure which one I'm going to do next, but I have a really good idea which one I'm going to do, as I've already kind of looked over it and like it quite a bit. But I want to save that for the next video for you to find out which one it is. But with that, that is the last of the deferred shading, and that is the no multiple render targets and for your deferred lighting passes. And very cool. Runs super old hardware and looks great doing it. Absolutely amazing. All right, so with that, my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.